Welcome to Ask and Learn.
So we need a formula to find the number of diagonals of an polygon inside a polygon. And let's say this is our formula. Let's try to prove it using induction. So let's use the base case n is equal to 3 because that's the smallest possible polygon. And a triangle has 0 diagonals. And let's use the formula 3 times 3 minus 3, which is 0 over 2, which is also 0. So that is correct. Now let's say n equals to k is in fact correct. Say this is k-sided. That's going to be k times k minus 3 over 2 diagonal. Let's say this is correct. Let's look at the case k plus 1. Therefore, let's say this is k-sided. So if this is k-sided, now we have an extra point to just the last uh, vertex. Then this every diagonal in here is going to be k times k plus 3 over 2. But that additional point gives us k more diagonals because it can connect it to, well, actually not the two of them. The two closest one are going to become sides. But then it will give me k minus 2 new diagonals. So plus k minus 2. And if I add it together, it's going to be k squared minus 3k plus 2k minus a 4. I believe, let me just look into this again. Yeah. So, what I'm going to do here is to look at the formula again, and let's look at the case, for example, with 4. We're going to have 4 times 10. Yeah, the formula is correct. So we're going to be taking our common denominator here. I'm going to have, um, so the new vertex is going to connect to all k sides, but it's going to create, here's the trick here. So what it's going to do is, it is going to create 2 new sides, but one of the old sides, which I'm going to put in blue, will not become a diagonal because we added a new vertex. Let me do it in the easier example. Imagine we have like a 5-sided shape, and green is 3 square, and we have 2 diagonals. If you add a new vertex, it's going to add these 2 new sides and 2 new diagonals. Well, look at it. One of the old sides is now diagonal 2. So I'll have k minus 2 plus 1, which if I use that for my formula now, I'm simply going to get plus 2k minus 2. This is going to give us k plus minus k minus 2 over 2, which is in fact k plus 1 times k minus 2 over 2. So the formula for the diagonals, if n is k plus 1, matches the formula that we have. Pay attention if you plug in k plus 1 into here, you're going to get exactly what you're expecting to get. So therefore, we have proven the induction.